Hi everyone, my name is Arianna and I work at Varnish Software as head of operations for support. And we at Varnish are focused on caching and CDN software. And throughout the last few years, we had the chance to work with content providers and broadcasters to help them building their caching setups and their content delivery networks. Today, I'm not alone, and I have the pleasure to have with me Devesh Gautam, Head of Edge Platforms at Rakuten, and Tushar Luhad, Principal Engineer at Intel. And we will be talking about 5G networks, and Devesh will provide a vision or really the idea behind 5G and what it means for Rakuten, while Tushar and myself will focus more on the practicalities of it and how we help Rakuten architecting and building a 5G cloud native network. The reason why we want to talk about 5G is because it will bring a lot of changes in the industry. 5G not only enables content providers and broadcasters to reach wider audiences, new regions, and new territories, but it also comes with the promise to provide a latency close to zero. That's what we define as low latency. And whenever we are able to deliver content with a time to first byte really close to zero, then of course you understand that opens up to a new world of new possibilities. But now, Devesh, I will hand the word over to you so you can share insights on what 5G really means for Rakuten. Please, Devesh.
Thanks, Ariana. Hello, everyone. My name is Devesh Gautam. I joined Rakuten almost 2 years back and majorly leading the initiatives for the multi-access edge computing, CDN, and the media services. And I'm very fortunate to be part of the exciting journey which we are doing at the Rakuten right now to building a fully cloud native LTE and 5G network at every layer, including RAN till the core, and we are going ahead with all the media services uh, building as a cloud native services only. Uh, so to the current topic, what is the role of the CDN in the 5G era? I majorly divide this overall situation in three dimensions. One is the enhanced mobile broadband, which is actually giving us the emphasis on the high bandwidth and the high throughput of the network, and which is actually primarily meeting the needs of individual internet users. Now it's shifting to the industrial scenarios like a manufacturing, production, medical, all the industry vertical. When speed is going to be 10 times more what we have today, it's definitely going to increase the use cases and enhance the possibilities and scenarios for the service providers, content providers, and the CDN. When speed is going to be more, people are going to use better bit rates. The consumption of the HD videos like 4K, 8K, and the camera deployment are going to be higher and higher. That is also giving the CDN opportunity and the role to have a criticality of CDN architecture, which needs the advanced accelerations, load balancing, and the storage capabilities like a multi-tier storage architecture, which we will talk about at the edge. And CDN definitely going to play a very important role in the face of the 5G era as compared to the 4G. The second dimension is the ultra reliable low latency applications like Ariana mentioned. When we are going, sub-second latency, it's opening up so many challenges and there's so many possibilities to explore the new use cases. So when we are talking about the URLLC applications is majorly for when you are transmitting, real-time data as a cloud, for example, a cloud gaming, virtual reality, unmanned driving, and the very exciting thing that is the medical use cases where you are going to enhance the medical capabilities for every users, be it in the remote village, they can get a best possible medical treatment with help of this 5G network. But how we can enable this? So there are two major enablers in the LLC, applications. The first one is how you are designing and the deploying your network, how distributed it is, how you are creating the balance of your compute, storage, and network across the network, where at the same time you are reaching to the extreme edge at the rural location or maybe a very high dense location. And at the same time, you are having a very thin layer of compute which is handling at the core location for offloading and for all other use cases which don't need that kind of latency requirement. So that distributed architecture is the first major enabler. The second most important point is how you are enabling the edge computing layer in your network. So, as a service provider with the 5G, there is a need when you have a layer in between the user and the CDN, which can create a closed loop system and provide the end to end user experience to achieve the local breakout, sniffing, and all kind of medical use cases and provide a better user experience. That is a great opportunity for the CDN providers to advance edge computing and application delivery capabilities to meet the new services enabled by 5G while tackling additional challenges like routing, content routing management, purging, and the security. And the third dimension, which I say that is use cases related to IoT, which we say in the 5G massive machine type of communication. So with the reach of the 5G, the throughput is increasing. You are covering the dense use cases. You can reach with the offloading, you can reach to the extreme edge. You are enabling the industry with a limitless device ecosystem. As the network grows, the need of the people also grows. And with the help of automation and the AI intelligence, the need of the IoT application is going to be limitless. It's going to grow many folds in the future. Maybe the today's CDN POP requirements to be in few kilometers for the user, but with the 5G, it is going to definitely be in the few hundred meters. And you should have to design your network such a way where you can reach to the extreme edge location to serve the customer. The overall definition of CDN will be significantly broadened in the 5G era, not only in the form of distributed content, applications, and the services, but this is also greatly expanded the network structure, business models, and the value chain relationship for the users, which is going to differentiate the entire ecosystem in the future. The overall use cases and the dimensions which is giving me the point of sense and the summarization in majorly three categories. The first thing is, as everything and the volume, the users, everything grows, at the same time the service providers and the OTT players definitely want a CDN as a commodity, because that is also giving them the opportunity to create a better value chain and a business model to reach each and every user. So the cost efficiency is must. The second most important thing is, as you grow, at the same time you have to maintain your quality of experience for the user, and at the same time you should have the agility to handle the analytics and get the real time feedback and enhance your system to serve the customer in efficient way. And the third and most important thing is scalability and the resiliency. There is no other option where you have to go to the cloud native way as compared to the current traditional ecosystem to scale in, auto scale in, and auto scale out, and have the auto healing kind of features to handle the scaling requirement as users are getting grows. And scaling is the, it's very hard. Akamai, level 3, and all had a same problem during their advancement, and when they started deploying the CDN. This is the only way where we have to handle the traffic growth and multiple users. So on this slide, actually, I'm more focusing on the edge computing strategy and what we are doing in the Rakuten. If you see the left side of the architecture, this was the yesterday where you are having a inode bees, and you are having a backhaul and the IP cores, and you are having a core location, and then you are going to the internet. With help of edge computing, you have to create a layer between the user and the main internet offload location. And as a Rakuten, we are already in the ORAN, the VRAN architecture. We have already distributed the backhaul, fronthaul, and the midhaul. And at the same time, we are creating at the center location a multi-access edge centers to achieve the distributed architecture to host our Mac applications, including CDN. At this location, we are doing the local breakout with the cups architecture. This is actually giving the agility, and we are achieving the latency reduction. We are doing the offload, the user's data offload is the key, which we say local breakout, we are able to achieve with this. And that brings me to the point that is also giving the flexibility to give to the market, go to the market with the majority of the three use cases. One is the infrastructure use case, the other one is the media services and the content delivery, which we are talking here. And the third one is the services to the businesses like enterprise. With help of the distributed architecture and the cloud native way, logically, you can create a cluster and you can deploy your CDN POP in any enterprise at the extreme edge location and achieve the maximum efficiency. And that is the fastest go-to-market strategy to reach it any location and closer to reach to the user. So just wanted to cover the currently why the cloud native is required for the CDN in the 5G era. If you see the current deployment model of the CDN, traditional CDN, one of the example across all the countries, 300K servers, very high network capacity, 40 Tbps, daily web traffic. But at the same time, the amount the CDN provider have invested in the capex, it's utilized only 33%, and that is also at the peak time. So 67% of hardware is still unutilized, but you have invested the money. So you definitely need a solution where your pods can scale on demand. They can have the optimal hardware utilization, a control on the operation cost, and because of that, you are also reducing the carbon footprint. And that is the biggest achievement and the agility which we can achieve as a CDN provider. So how to solve this? The solution is to go the cloud native way. And how we can achieve that? The first step is we have to decouple the software and the hardware. So with help of Varnish and Intel, we are achieving this in the Rakuten, where we are have completely disaggregated the software and hardware to deploy the CDN with the microservices architecture, where the caching is one of the microservice. At the same time, the request routing is one another microservice which you can scale in and scale out. Just an example. And that is giving us the shortened time to market to innovate more services, more agility to push more features. We can go to the market with very thin layer of features. At as your customer grows, you can incorporate the use cases with help of microservices without any disruption in your network. The second is, with this approach, you are optimizing your hardware utilization, you are reducing the energy consumption. So that is reducing your capex plus opex, both cost. So you are having more bracket to give better plans and the bundle services to your users. The third most important cost is when you are managing your OPEX and the CAPEX in a way where you are reducing the hardware, you are having the flexibility to create a different plan for enterprises. You are having a different plan for the B2C customers. You are having a better visibility to entire value chain system to the entire industry. The fourth very important part is hardware, software, and then microservices. Above and all, if we are having a orchestrator layer which is actually giving us the elasticity to handle dynamic high volume demand with the auto scale and the auto healing, that is giving the completeness to the cloud native architecture. And the last and most important part is with help of this we can provide the high throughput, low latency with the edge computing strategy, and we can provide the smooth media delivery to according to the category of the users. If there is a user who is very close to my CDN POP, can get a better or maybe optimized smooth delivery. At the same time, if user is at the far edge location, still that user can get, with the help of microservices on the request routing and the bitrate enhancement, can get the optimized services and have a better media delivery. So why we are doing this? Rakuten is not a telecommunication company. We are spread across approximately 70 major industries and verticals, where we are enabling the industry with help of our connectivity platforms, Rakuten Mobile, the cloud native platform, Rakuten Communication Platform, RCP. We are enabling the industry with our banking services, medical, advertising services. We are also at the same time we are empowering the society with the energy, with the wallet, with our organic Rakuten Ragri, with the Rakuten Pay points to enable the society for each and every need of it. And the third one is we are enriching the individual experience. We are reaching to each and every partner and the user to fulfill their needs in all the verticals, like a travel, for the social media platform like a Rakuten Viber. Rakuten TV is giving the enhanced content and the media delivery. We are having a partnership with the major sporting leagues, including Rakuten Eagles, Barcelona, Vissel Kobe, Rakuten Monkeys, and that live streaming is one of the key to enrich the individual experience. So this says there is a need to handle all these rich content, which as a company we are having in our genes, and we definitely need a platform at the same time when we are moving towards the 5G to reach each and every user in that more efficient way and more agile way to achieve best user experience and cater all the best possible innovative and the current market trends to compete in the market, as well as to partner with the providers and the players like Intel and the Varnish in the future, and that should be a goal for the Rakuten to go ahead further. Thank you.
Thank you, Devesh. My name is Tushar Gohar. I work at Intel as the principal architect for content delivery and edge storage. At Intel, we have had a dedicated focus on CDN from a hardware and software optimization focus. Today, I'll give you a glimpse of a few challenges in this problem space from an infrastructure and orchestration point of view and what Intel is doing to address those. As a close partner, we have been witness to Rakuten's world's first end-to-end cloud-native network from access to core. We have been part of their journey onboarding these infrastructure network functions from virtualized radio access, media to content delivery. So let's talk about this part in this journey. So before we move on to CDNs, let's take a moment to recap a few key tenets of cloud native edge that Devesh already touched upon. Cloud native edge rests on scalable, programmable, intelligent infrastructure, dynamic resource management, automation, and zero-touch provisioning. Add to that also edge analytics, which is becoming an important pillar as well, where data from edge nodes is used for fault detection, fault prediction, and even policy-driven decisions of resource allocation and reallocation. At Intel, our approach to cloud native edge is three-pronged. The core of our offerings is, of course, hardware. We offer compute, network, storage, and accelerator solutions to meet all the needs of the edge applications. Intel's mission has been to make a standard server platform into a best-in-class network infrastructure platform. The second pillar, of course, is the developer tools. We have been investing in open source and SDKs like OpenVINO, Open Visual SDK that make it easy for developers to build AI and visual cloud pipelines. These modular software blocks are designed to work well together, which allow building edge apps with ease and help unleash the power of the underlying Intel platform. The third side to this triangle is basically the ecosystem. We foresee that the IoT and cloud developer ecosystems would converge at the edge, and our role is continuing to accelerate this trend. CDN is a competitive space. Driving down costs remains the top priority for CDN operators. they must at the same time keep up with the rising demand. This table shows the content types that CDN operators have to deal with in the field, along with their compute, network, and storage memory, and of course, growing security needs are shown here. The primary thing to note is that all content is not equal. It's one thing to cache and serve static content like HTML, JavaScript, static images, and it is another to deliver video. Live content needs small to moderate capacity, but high endurance, whereas video on demand is more capacity centric, where a platform needs a large storage capacity available. Other aspects such as the growing need for TLS at multi-100 gig speeds makes the high core count CPUs and NVMe storage for video on demand a necessity, making the cost challenge even more real. Given the heterogeneous mix of workloads that CDN is, capacity planning, particularly for cloud native CDNs, poses an interesting challenge. Purpose-built appliances, like Devesh covered, the traditional way of doing CDNs are just not the answer to predicted growth of content across the world. So the challenge here is in consolidating CDN service delivery on a single, scalable, multi-purpose, but yet cost-effective standard server platform. So towards this scalable standard server platform for a modern high-performance CDN, let's take a look at what Intel has in the toolbox. Our Xeon family of processors comes with instruction sets that are optimized for crypto, AI, and video processing. We also have recently invested in custom CPU SKUs that are optimized for CDN-like workloads, where we are able to offer about 20% higher throughput and lower latency at similar cost. Our NICs or network interface cards offer 100 gigabit capability with features like ADQ, which stands for application device queues, which bring consistent latency and lower time to first byte, which is an important metric for CDNs. Next, storage, which is a key requirement for CDNs. As CDNs move to 100 gigabit networking, NVMe storage is fast becoming the norm. Intel has been innovating in the space for almost a decade now. Our write-intensive TLC SSDs and read-intensive QLC SSDs are some of the most mature solutions on the market, offering some of the best dollar per gigabyte price points for video-on-demand workloads. Looking at the next workload at the bottom of the slide, we have live video delivery, where you need a high endurance media. So Intel's Optane persistent memory offers a solution which is denser than DRAM with a significantly lower price point, but offers similar latency characteristics as DRAM for the live linear workload. Next, let's talk about the orchestration pillar of cloud native CDNs. An edge orchestration stack with intelligent workload placement capability is the key. Add to that the requirements of the 5G era, being able to discover near and far edge nodes with the right feature set from a compute network storage standpoint, and meet the changing demand, bringing or scaling in and out resources is a big requirement for the next generation of CDNs. Intel has been working on a set of such orchestration building blocks as part of an open source project called Openness. It stands for Open Network Edge Services Software. It's a platform that enables onboarding and management of edge functions with cloud-like agility. Openness abstracts network complexity, provides cloud-native orchestration, and hardware and software optimizations out of the box for best performance and ROI on Intel platforms. You can pick and choose from microservice recipes, platform awareness building blocks, or something we call experience kits, which are readily deployable playbooks for edge usages. Rakuten team's recent endeavors in radio access network, media, and CDN services serve as great proof points for openness in its platform aware, or better yet, performance aware scheduling capabilities. We still have some areas of improvement in the orchestration space, be it exploring the scale out storage from a cost efficiency standpoint, which is basically decoupled storage from compute to make it more stateless, or power management and workload placement to enable CDNs at the far edge. However, looking at Rakuten's success in virtualizing every layer of the network, we have an evidence that cloud native is the way forward for building CDNs of the future. Next, to talk about a key piece of the CDN puzzle, which is data plane software, we have Ariana from Varnish. Thank you.
Thank you very much, Tushar. Thank you for your insights. I think we can move to the next slide, and I will also take the opportunity to thank Devesh for providing the vision around the 5G. Okay, let's move and let's discuss a bit the role of software in a 5G CDN setup. Because as you have understood by now, Intel and Varnish Software work together with Rakuten to actually build a 5G cloud native network. And while do so, we have understood we need to have 3 must-haves whenever we talk about 5G CDNs. The first one is cost efficiency. And that's because 5G opens up to new audiences, to new regions, to new countries and new territories. And of course, this translates into more viewers, into more traffic, into more requests per second to be handled. And whenever we deploy new software, whenever we build new software, we want to make sure we're capable to welcome this new traffic and still stay extremely cost efficient and still use the resource we have available. The second point is scalability and resilience. When we talk about 5G, we are actually talking about a fully virtualized CDN setup. And this means that the software must be capable of scaling up, shrinking back, scaling horizontally, scaling vertically, and we must be capable of welcoming any kind of traffic patterns and any kind of changes. And that's something Varnish can accommodate very well. And at the same time, it can also provide resilience, which means that upon an unexpected peak of traffic, we're capable of protecting the whole infrastructure. And last but not least, it is performance and agility. This really brings me to my next slide. Performance for us at Varnish Software is extremely important. And it really means that whenever we talk about performance, we want to make sure that our software is capable of making the best use out of the hardware we are given. And to prove it, we often run benchmarks on hardware optimized for CDNs. For us, it is important to be able to saturate the network cards, the most modern network cards. And in one of the benchmarks I would like to talk about for a second, we have tried to saturate 200 gigabits per second network cards, keeping the latency close to 0. Those are the benchmark results. And we cover 3 different use cases. The first one is the optimal use case, where all the content is served out from cache, 100% of the traffic served out from cache. Then we have 90% of the traffic served out from cache, and eventually 80% of the traffic being served from cache. Please bear in mind that these values are perfectly real. It's very likely that whenever you serve a video, you might get 80%, 90%, or 100% of the content be served out from cache. And as you can see, in the very worst case, we managed to serve close to 160 gigabits per second out of the 200 gigabits per second available from the network cards. And in the best scenario, we got very, very close to 190 gigabits per second. That's 95% of the available bandwidth, which means that we have been able to saturate anything between 80% and 95% of the available bandwidth. And we did it keeping the latency below 33 milliseconds. And to me, those are stunning results, in my opinion. And this sort of proves the point that software and hardware must cooperate in order to be able to deliver great quality of experience for the end users. So these slides really sum it up very well, the work we did together with Intel and with Rakuten. But then, of course, there are more general takeaways that we could get from this presentation. So 5G and the cloud native model brings the promise of agility, scalability, cost efficiency, and reduced time to market. But of course, these promises and these benefits, they do come with challenges. And the challenges can only be addressed with a smart mix of hardware, software, and resource management. Thank you very much, everyone, for taking the time to listen in. And I would like to thank again Tushar and Devesh for taking part in this presentation. And I will now hand over to questions if you guys have any. Thank you.